Welcome back to another episode of the Hacklab Podcast Safety Leadership Series, where we bring you real conversations with safety leaders shaping the future of workplace safety. Today's episode is about a gap we see in many organizations. Occupational safety can look strong on paper, for example, PPE compliance, LTI reduction, and good TRIR. Yet, process safety risk can still be sitting silently in the system. So the question arises, are we only preventing injuries or are we also preventing major accidents? To unpack this today, we are joined by Dr. Stephy James, Associate Professor, Safety and Fire Engineering at TOCH Institute of Science and Technology, NEBOSH approved tutor and HSE trainer and auditor with National Safety Council, with strong expertise across HIRSA, QRA, electrical safety, fire protection, and process safety. Dr. Steffi, welcome to the show. It is
Thank you.
great
Thank you, Amber.
to have you with us.
Yeah, thank you. Thank you, Amber. Nice to see you again. Great.
Yes. So, before we start the conversation, can you please
Yeah.
give us a short introduction about yourself?
Yeah, I'm Dr. Stephy James, Associate Professor, TOCH Institute of Science and Technology. I'm an approved NEBOSH IDIP and IGC trainer, and I'm a HSE trainer, and I'm occupational health and safety expert and industrial consultant, safety auditor, fire load calculation, and various other in quantitative risk assessment studies, electrical safety, occupational safety, behavior-based safety, and chemical construction safety for and expert for various other subjects. And presently, I'm doing as associate professor in Department of Safety and Fire Engineering. 18 years of experience I have, and that's all about me. Yeah.
Okay, perfect. So, let's get started.
Yeah.
When we say occupational safety versus process safety, so how do you explain the difference in the simplest possible way?
Yeah. Think of this way. Occupational safety is about protecting individual workers from the hazards they face day to day. For example, they may slip hazards, trip hazards, falls, chemical exposures, maybe like acid spillages or anything like that, or ergonomic strain. All that things are occupational. But process safety is about protecting the plant, the community, the multiple lives from a catastrophic failure in the process itself. That may be an explosion, a toxic gas release, a fire accident, fire caused by loss of containment, a tank failure. So this is the simplest analogy. Occupational safety asks, is the worker safe from the work environment? Process safety asks, is the environment safe from the process?
Okay.
So that is a major difference between process
Okay.
safety and occupation safety.
Okay. So, why do some sites show excellent TRIR and LTI performance, but they still remain vulnerable to major accidents?
Yeah. Total recordable incident rate and lost time injury. This is one of the most dangerous blind spots I encounter during my audits. I have conducted around more than 20 audits because TRIR and LTI measure personal injury frequency, maybe like cuts, burns, or sprains, or near misses involving individual workers. They do not measure the health and safety barrier protecting the process. So major accidents are often described as low frequency or high consequence events. They can build silently for years. A relief valve is not tested, a safety instrumented system is bypassed, a bund wall is compromised, preventive maintenance is deferred. None of this creates an LTI entry, but they create the exact condition for a Bhopal or Texas city. So this is what the reason. Just Swiss cheese model says that holes in individual slices in the barriers may not be visible in lagging metrics, but when they align, you may get catastrophic penetration. That means every individual protective layers are breaking to create a very big disaster. So in my experience, I often found that the sites most confident in their safety performance because of good LTA numbers are the ones with most degraded process safety barriers. Because of the absence of injuries creates a dangerous sense of normalcy.
Okay, okay. So, Dr. Steffi, just want to understand something from you. So, occupational safety and process safety. So, in companies, do we have separate checklists for both of them, or are they run in parallel or in series? How does that work?
Yeah, during audit, we used to have IS 14489 audit formalities there. There is no separate audit formality for occupational checking, occupational safety and process safety. But still, if the company asks you to specifically concentrate on process safety, then we will prepare a separate checklist to concentrate on process safety alone.
Okay.
Why? Because I can simply understand this matter. If suppose taking a construction industry, another industry is a process industry. In construction industry, there will be more frequent accidents, like small cuts will be there, falling from height will be there, injury will be there, small accident will be there. So frequency of accidents will be very high, and the severity of the accident will not be much high, because maybe maximum is one fatality, one person falling from height, he died, or maybe some spinal cord injury, or maybe a lost time injury, a fracture, all that things. But if suppose a process industry, any leakage or a toxic gas release, explosion happen, that very rarely happen. Suppose happen, thousands of people will be affected.
Right.
So that is the difference. In construction industry or occupational safety, the frequency will be high, but the consequence will be very less. But the process industry, the frequency will be very less. But if suppose happens,
yes, it makes sense.
Consequence will be very high. Bhopal tragedy example, Dixborough disaster example, Chernobyl disaster is an example.
Right. It's one of a lifetime event, but it's a very catastrophic event.
Yeah. If suppose it happens, just like if nuclear power plant is just nothing but a nuclear bomb.
Yeah.
Chain reaction is happening. So if you are not protecting that nuclear power plant in a very so many layers of protection, it will retaliate, backfire, and that impact will be very high. The impact of a process safety accident, like fire, explosion, a toxic gas release, like Bhopal tragedy or Visakhapatnam styrene gas release, LG polymers, or maybe you can say Chernobyl, I said, and Beirut explosion recently happened some 5-6 years ago, ammonium nitrate explosion in Lebanon, Beirut explosion.
Yeah, the video is viral on internet, right?
Yeah, Beirut explosion, ammonium nitrate, highly explosive.
Okay. I see.
So we should be very careful in protecting the process industries. There will be very less occupational accidents. The process accidents impact will be very high. That's a major risk.
Understood. So what are the most common process safety failure patterns you have seen during audits?
Yeah. So according to my experience in the refinery, petrochemical, LPG storage, and the manufacturing, other industries, audits, and other experience, the barrier degradation without visibility, safety critical equipments, probably like PSV, pressure safety valves, pressure transmitters, high level trips, are out of service or bypassed without proper maintenance, or without a proper management of change process, or control room shows green but the physical safety barrier is missing. This may be a problem. Or maybe weak alarm management, control rooms with hundreds of active alarms, many of which operators have learned to ignore. That's a problem. Or poor isolation and energy control, especially in maintenance. Lockout, tagout procedures exist on paper, but the actual practice, they may not follow. Energy sources are not fully isolated before the maintenance. That may be a problem. Or absence of verifications, ineffective management of change, MOC, and weak shift handover. That's another problem. In Chernobyl disaster, what has happened? The shift handover, the previous shift, those people are working, they have to inform the new person joining for the shift what is existing, what is the present condition perfectly. Otherwise, there is no communication. The new during the shift handover, a lot of problems can happen. Safety critical information not systematically transferred between the shifts, leading to operators being unaware of what is going on, what ongoing abnormalities, and they may bypass or process deviation. That may be a problem. That is weak shift handover procedures. Shift handover.
Okay, got it. So, what are the typical early signs or early warning signs that major accident risk is building up inside a plant?
Yeah, I can call this as a drift signal. They appear subtly, no, long before the catastrophic event. The early warning system may be increasing the frequency of safety critical equipment overrides and bypasses, especially when normalized. We always do it safely, but rising number of near misses involving loss of containment, maybe even minor leaks from flanges, seals, or normalized deviation from operating procedures. That is, SOP will be the standard operating procedure. They may deviate, or deterioration or preventive maintenance compliances, alarm rationalization delay, or maybe loss of competency in process hazard understanding. Production pressure, that's a major problem. Production pressure always overriding safety decisions. We always give priority to production than safety. So that times we have to be careful.
I see. So, Dr. Steffi, I was
And
thinking
also,
that,
one more thing, and I often say in training, a plant does not go from safe to catastrophic overnight. There will be warning signs are always there. The tragedy is that they are often invisible to those who stop looking.
I see. So first, I would like to ask you, during the training of such professionals, are they taught of these invisible warning signs to look for these signs? That is the first part.
Yeah, training is actually very important accident prevention system. First 5 E's of accident prevention is there. First one is education. We have to give proper education to the people. Next one is engineering control. Engineering control means, like, we have alarms, different protective systems, fire preventive system, detectors, all control systems, control room, valves, all type of protective systems. That is engineering control. Guardings, everything will be engineering control. And third one is enforcements. Why in India road accidents are high? Because lack of enforcement. Camera is there, camera is not working. Policeman, if we give some bribes, or nothing. So enforcement, the fines, traffic fines are not high. If the government is taking a good governance decisions for the enforcement, that may be in police department or in factory or anywhere, proper enforcement is there. Definitely the people mind will change. Okay, if I am doing some mistake, there will be some court fine, imprisonment, or maybe violation. They will cut our license. So that fear will work out. So enforcement is one very important thing. And another one is example setting. If I am a safety officer, I should be a role model. Then only we can insist others to be that. And enthusiasm. Safety should, if you, we have to give award, reward. Those people are doing best practices. We have to recognize them. So these are the 5 E's: education, engineering control, enforcement, enthusiasm, and example setting. In that education, training is very, very important. So we have to give exclusively special training for particular activities. Induction training is there for people, those who are joining new. Specific training, welding training. Then maybe the people are doing this one. This radiation hazard is there. Special type of training is required for radiation activities and all that. So training is very, very important, and specific training can be given and people can be make aware. That is only one method. Training can be given. Otherwise, if suppose somebody doing unsafe act, first we have to warn. Letter can be given, memo can be given. Continuously they are doing mistakes again and again. Then we have to terminate him from the industry. That's all.
Right. Okay, and my second part was, suppose I see something is going out of control, then do we train for such scenarios? That what is the chain of command once that happens?
Yes. We always in training, now virtual type of training is there. Original scenario we are demonstrating. They can see by using the virtual reality cameras and all, they can view original scenario. So they will get an exposure that if suppose an original accident happened, what you have to do. So that type of training we are giving now. So they will be more mentally prepared. So what we should do. They originally seeing the scenario, fire, explosion. Just like we driving, games are there, no car,
Yes.
terrain, roads, and same
Yes.
type of training we are providing. Right? It's very costly, but it's available.
Right. Right. That is, I think, very good. Yeah.
Yeah. Yes.
Okay, so moving forward, how should organizations think about barriers like engineering control, procedural, instrumentation, human action, and
Yeah.
which barrier fails most often in real life?
Probably there are different types of barriers. Are there categories? Are there engineering barrier means the physical safeguards like pressure relief valves or rupture disc, burning, fire suppression systems, and all. Instrument barriers means safety instrumented system like high trip systems, automated responses, and all that thing. Procedural barrier means the SOP, operating procedures, permit to work system, emergency responses. Human action barriers is operate response to alarms and all. In my experience, from audits and all incident analysis, the procedural and human action barriers fail most frequently. Human error, more than an equipment fails, human being.
Okay. Dr. Steffi, like
Yeah.
you're saying human failure, right?
Yes.
So if we reach a point in future when, humans are replaced by robots, humanoids, right? So do you think the safety will shift to a new risk or the safety will be reduced?
Oh, that's a hypothetical question.
Yeah.
Yeah, now most of the cases where there is more chance of human error or where there should not be any error at all, most of the things are automated. Now itself it is automated.
Okay.
We cannot completely rely on robot or anything like that. Some human intervention is required. It's decision making. We completely rely on robotic or any artificial intelligence or something like that, mimicking the human brain and all is there. We don't know what we expect as the decision in a particular scenario, what robot or what machine learning, that there may be, realistic problems will be there.
Yeah.
So we cannot completely rely on robotics or anything like that. But in most critical scenarios where human error is not at all possible, we cannot allow any single error. We have to be automated. But final control should be in the hands of human beings, and otherwise, human beings may be, what we can say,
getting extinct.
Yeah, it's just like an alien. They act like an alien. Some other machine can conquer human brain. In that situation, of course, that's a disaster of humanity.
Right.
That will be the complete enmity. If the machine, robot can conquer us, we don't have any control over robots. We generate robots, we create robots. That robot start destroying us.
Yeah.
Then it is the disaster, no?
Absolutely. Okay, so moving forward into reality. So where does HIRAC stop being sufficient, and when do the tools like HAZOP, LOPA, QRA become necessary?
Yeah. HIRAC means Hazard Identification, Risk Assessment and Control. It's an excellent tool for managing everyday occupational hazards. We can list out so many hazards and we can identify the hazards and we can prioritize which activity has the highest risk and all. So the hazard scenario involves multiple interacting failure modes that cannot be adequately captured in simple metrics. So this process involves large invention of flammable, explosive, toxic material, all that things. And you need to demonstrate that the risk is as low as reasonably practicable. We find out the risk, and if the risk is high, what do you want to do? We have to apply additional control measures so that we have to reduce the risk. That is the method of HIRAC. Whereas HAZOP, LOPA, and QRA become necessary, especially in chemical industries. HAZOP is actually used to systematically identify the deviations in process parameters like low pressure, low temperature, more flow, high flow, all that process parameters. So what are the consequences of that? To identify that, we use HAZOP. And LOPA is the layer of protection analysis, used to verify the sufficient independent protective layers exist to reduce the risk to a tolerable level. So it bridges qualitative HAZOP findings with quantitative adequacy. That is LOPA. And QRA is actually used to calculate the individual and societal risk by using some softwares called FAST, FET, and all that thing. So often required for land use planning around the major hazard installations, whether it is a populated area and all. If suppose from the tank, if it is LPG or LNG, if it leaks, how much area it will be affected, all that can be calculated by using this QRI. So regulatory compliance and insurance purpose also we use this. My own PhD research applied subcomputing techniques to enhance LNG storage QRI studies. So in simple terms, use HIRAC for what can hurt you today and HASOP LOPA QRA for what can destroy the plant and hurt community tomorrow.
Okay, got it. So what are the good leading parameters for process safety that leadership should review on a monthly basis?
So this is a critical area where most organizations are underperforming. Leadership reviews lag indicators like LTA frequency, incident count, severity rates. So this will tell you that what already went wrong. Leading indicators tell you where you are heading. So the leading indicators I recommend for monthly process safety review: safety critical equipment overrides and bypasses. How many safety critical devices are currently bypassed, overridden, or a trend over months, or preventive maintenance, or process safety near misses, or high demand alarms, permit to work system, like that. So emergency shutdowns, test completion, or functional safety test, or for SIS, that is safety instrumented system, or ESD, emergency shutdown system, being completed on schedule. So the message for leadership: if you are only reviewing LTA and TRIR monthly, you are reading last month's weather report, not today's forecast.
Okay. They are telling us about the last month's stuff, not today what is going on in the plant. Okay. So how do human factors show up differently in process safety compared to occupational safety?
So that's a very important question. Human factors in occupational safety typically manifest at the individual task level. A worker not wearing PPE, personal protective equipment, not following a procedure, he is taking a shortcut on a routine task. These are visible, correctable, and usually produce immediate consequences also. In process safety, human factors manifest at the system level. The consequences are delayed, often invisible, and can compound over time also. So fatigue and shift work in continuous process plants, operators managing complex system over 12 shifts in the week, rotation are cognitively impaired. So overconfidence and normalcy base will be there, and also maybe alarm fatigueness, shift handover failures, decision under pressure. So distinction is important for intervention design. Occupational safety often responds to individual behavior. Individual behavior changes, but process safety, human factors require systematic solutions, better alarm management, or shift handover protocols, or something like that, or competency assurance is also, and a culture where raising safety concern is rewarded, not penalized.
Okay, understood. So in your view, what does a strong process safety audit verify on the ground beyond the documents and checklist?
Yeah, this is where I believe most audits fall short. Normally we have a checklist of document and checklist compliance gives on a partial picture. A strong process safety audit must go beyond the paper. So that is a very important thing. The control room and the failure. So when I personally verify on the ground during the process safety audit, physical condition of the safety critical system, like RPSV, physical accessible for testing, or operator knowledge testing, bypass and override register verification. So that may not be in the checklist. We have to do that. So control room situation awareness, permit to work spot checks, near miss culture assessment. In the checklist, maybe some standard thing will be there. We have to assess what is required for that particular industry.
Right.
Based on that, we have to do. So management walk through quality. All these things. So underlying the principle, the paper says what was intended. The field tells you what actually happens. You have to go to the field, And not only the checklist, you have to physically verify what goes wrong. A third eye. Third party inspection is a third eye.
Yes.
So whatever the routine people, what they say, a third person can find out easily. So a strong audit always closes the gap between the two.
Okay. So finally, if a company wants to improve, safety in this quarter, what are the top 3 practical steps to strengthen process safety?
Yeah, maybe because of the organization that you try to everything at once, often achieve nothing. Mainly the 3 steps are like one, know your barrier status. That is, conduct a rapid barrier verification exercise on your top major accident hazard scenarios. For each scenario, map the engineered, instrumented, procedural, and human barriers. So that is the first thing. We have to understand the barriers. Then the next one is fix your leading indicators dashboard. At least 3 process safety leading indicators to your monthly management review. I recommend starting with safety critical equipment bypass status, overdue safety critical PM stars, and again the process safety near miss count. They do not require software investment. A simple spreadsheet is enough. Excel sheet is enough. Updated by the safety team, reviewed by the leadership monthly, already changes the conversation from how many injuries to how strong are our barriers. And the step 3 may be, the step 1 I told is your barrier. Know your barrier status and fix your leading indicators. And third one is invest 1 day per month in field-based process safety learning. You have to just make a tour. Designate 1 shift per month as a process safety learning shift, where a cross-functional team, including operations, maintenance, and safety, spends 2 to 3 hours doing structured walkthrough, focused specifically on process safety. Asking the operators, what if questions? If suppose that fail, what if? If this is fail, what if? Like that we have to ask. Checking the physical status of the critical safety devices. Reviewing current bypasses. And maybe they can discuss a recent near misses or industry incidents. They can ask what happened over there. We can investigate.
Right.
So this builds process safety competency without the need for a large training program. So overreaching a message, the process safety improvement does not require a new management system or a consultant-driven program. It requires leadership visibility, honest field verification, and the discipline to treat barrier integrity as non-negotiable. That's
Perfect. Great.
So the real measure of safety maturity is not how few injuries you record, but how well you understand the risk, what is already present in your industry, in your process, and how actively you are managing it. Great occupational safety numbers do not mean the plant is safe. They mean the plant is preventing injuries. The process safety means ensuring the plant never becomes the hazard itself. That's important.
Okay.
Yeah.
Wonderful. Thank you, Dr. Stephy. This has been a very powerful and insightful conversation because it reminds us, the great occupational safety numbers, like you said, don't automatically means process safety is under control.
Yeah.
So occupational safety protects people from frequent lower consequential events, but process safety is about preventing rare and high consequence events that change lives, shut down operation, and permanently damage trust.
Yes.
Yeah. So thank you once again, Dr. Stephy, for bringing clarity and practicality to such an important topic. To everyone listening, if you found this episode valuable, do share it with your EHS team, operations, plant leadership team, and follow the Hacklab Podcast Safety Leadership Series for more conversations like this. Until next time, stay safe, stay alert, and lead safety with intent. Take care and have a nice day. Bye-bye.
Thank you.